Imagine breaking a lampshade and having a replacement for it in hours without having to leave the house. Owning a 3D printer allows you to make replacement parts for things around your house as soon as you need them. It's even possible to create personalized furniture, like a lampshade you designed yourself. Stick around and I'll show you how to create a lampshade like this one using a custom print pathing algorithm for your house too. A great way to easily make replacement parts is by using a model sharing site online, finding a model, downloading it, and slicing it in your slicing software of choice, printing it and calling it a day. In fact, I came across 3 models just by searching on printables for a couple seconds. Another great way is to design a model in a CAD package like Fusion 360, but I'm a glutton for punishment, and no, I said I don't want to take the easy way out. I want to code a toolpath generation algorithm and spend multiple months fine-tuning it to create something new. And sometimes I don't make the best decisions. I didn't use an existing model, and I didn't create a CAD file to slice with an existing file either. Those are the 2 popular methods to create something with your printer. So what was my process to create this lampshade? The final way to make instructions for your 3D printer is to code your own algorithm that creates the desired shape and then generates G-code instructions for your printer based off this. This is generally very difficult and time-intensive to do, as these methods generally only work for one type of geometry. This is something I definitely don't recommend for someone who isn't willing to put the time in and a lot of effort and learn along the way. I knew that using this method is the only way to achieve the look I was going for this lampshade. Making this lampshade was an arduous process of trial and error. I'm up to my 18th revision and it still is not perfect. I was editing the amount of plastic extruded, layer height, minimum and maximum, and printing speed, such that I could print the part with as little errors as possible. All of these parameters are modifiable via the Grasshopper script itself. To print a part like this, you also need to make sure that your printer's nozzle area is relatively free of other objects, like a print cooling fan, that might get in the way of the part due to the fact that each layer is, moving up and down. So there are a couple ways to create a unique print pathing algorithm, and Full Control is a really awesome project that allows a user that is experienced with programming and 3D printing processes to create G-code files for a printer using mathematical functions that you would define yourself. The way I did this though was by using a CAD package called Rhino and the associated Grasshopper with it, which is a visual flow-based programming language within Rhino to create the final G-code. So why did I go to great lengths just to make this lampshade using this technique? Because it's currently the only way to create non-planar G-code for this shape that gives this lampshade's layer lines curvature that really looks natural in my opinion and adds to the look of the lampshade overall, instead of having planar layers which would detract from the overall look of the lampshade. I really wanted to make a lampshade with my 3D printer that was unique and something that I enjoyed looking at day in, day out, because it's a lampshade. The algorithm I used to create this lamp was derived from a book titled Advanced 3D Printing with Grasshopper that I ran across a while ago. To make this lampshade, the printer will literally follow the curves in the model with the nozzle during the print, creating an effect where each layer printed gently follows the shade's natural curves. To make this effect possible, in each layer there are sections that are taller and shorter according to the natural geometry in the lampshade's curves. These effects create for a lampshade that has gentle curves that, to my eye at least, look really beautiful, which it should, because this is a lampshade that is going into my home office and future videos. To create this lampshade, I first modeled the general shape I wanted to achieve in Rhino. I learned how to create this shape and the general procedure for this print through the aforementioned book. In it, it spells out how to create a similar Grasshopper program, but it can also be a little hard to completely understand at times if you aren't familiar with Grasshopper and CAD already. I won't get into too much detail about how to do modeling and creation of the Grasshopper program here, but if you want to learn more, there are a lot of great resources on YouTube and the Rhino forums. At a high level, what this program is doing is taking the curves I modeled in Rhino and performing a geometric operation called a loft to create a thin-walled object. This shape is what we then feed to another algorithm to create instructions for the 3D printer. On a high level, this consists of taking the generated shape as input to more functions that look at the surface curvature, create curves that express the shape of the surface, and then modify those curves into small lines that approximate the geometry of the curve. And then finally, create the text file format needed for the printer to understand what it needs to do to create the shape. The output text file are the instructions that a 3D printer needs to create a part. I've created a Grasshopper file and Rhino model of this lampshade that is easier to print for you to try out if you're interested, and that'll be in the description below. Rhino is a full-fledged CAD program that is used in architecture, arts, modeling for video games, and other fields. As such, it costs a pretty penny to purchase outright, but the company that makes Rhino also has a relatively long-lasting free trial that you could use to play around with the file I generated. I used Prusa Slicer to create planar G-code as well. This is what it looks like. As you can see, when you compare both together from a distance, they look pretty similar. But when up close, the vase I generated using the custom Rhino script has curves that moves with the overall shape's curves as well. This is a subtle effect, but I feel that it makes the layer lines look intentional versus just an artifact from the production method itself. Whether you create your own art with 3D printing, or you are printing models you found on a model sharing site online, 3D printing is a great way to make useful objects around your house. I encourage you to start thinking about how you could use a 3D printer to make replacements of something you have lying around the house. And consider sharing it with the world on a model sharing site like Printables. Printing stuff you find around the house is a great way to be a little bit more sustainable, save some money, learn a new skill, and be creative if you feel like it too. Thanks for watching this video. Leave feedback in the comment section below and let me know if there are topics you want me to cover in future videos. My goal is to grow this channel, continuing to post videos about useful projects that create something new or improve upon what the hobbyist community has already developed in 3D printing for the benefit of the entire community using these machines. See you next time.